Hey, what's going on, folks? We're going to hit up the rest of 7-3. We're talking about empirical formulas. Let's hit the example problems right off the bat. So we have 7-13. That's the example problem I'm looking at. We have some compound that has nitrogen and oxygen in it. And I can tell you how much percent of nitrogen it has in it. And I can tell you how much percent of oxygen it has in it. It has 25.9% of nitrogen, and it's got 74.1% of oxygen. Cool? Now, the way I would attack this problem is I say, if I started off with 100 grams of this stuff, then how many grams of nitrogen would I have? And how many grams of oxygen would I have? If I started off with 100 grams of this stuff, so I'll put if 100 grams of this compound, 25.9 grams of that would be nitrogen, and 74.1 grams of that would be oxygen. Does that make sense? Okay. How many moles is 25.9 grams of nitrogen? I'm just going to ask the question. I'll let you figure it out. How many moles am I dealing with here?
One.
You don't know?
No.
If you don't know, it's fine. We have the amount of grams we have. And remember, I was keep telling you that molar mass thing, that trick that they have in the bottom of the periodic table, that's to help you convert from grams to moles or from moles to grams. So we have the number of grams, and I just asked you how many moles are there. So the first thing I would look for is
12.
12. Okay. So wait. 12 is what? That's carbon.
Oh.
Yeah.
14.
I'll give you a hint. Whenever you're studying chemistry, print out an extra periodic table and put it like on your wall right next to where you study. Because you're going to be using it a lot, especially when we get to chapter 6, 7, and 8. Or 6, when we're talking about chemical nomenclature and naming the chemicals. Those are going to be really important. So you're going to definitely need to know your chemicals. And you're going to need to memorize a whole lot of stuff in chapter 6, which is why I didn't start in chapter 6. I started in chapter 7. Because I'm a physicist, I'm a mathematician. This math stuff is more my cup of tea. But we'll go back to chapter 6 and nomenclature when I feel like I'm ready to teach it, to show it to you. Because right now I don't even. It's been about 8 years since I've taught nomenclature. That's a little bit tougher topic for me than this stuff. So if we had 100 grams, we would have 25.9 grams of nitrogen. And in order to convert that, I would need that number down there. And we know that for every 1 mole of nitrogen, it has a mass of what? 14. So I put grams on the bottom or grams on top?
On the bottom.
To cancel out with this grams. 14 grams. Is it 14.0? I want 3 sig figs.
Yeah.
14.0 grams of nitrogen for every 1 mole of nitrogen. All right, what's 25.9 divided by 14? .85. Okay. And this is moles of nitrogen. So what I'm saying that if I had 100 grams, I would actually have 1.85 moles of nitrogen. Let's try, let's do oxygen while we're at it. We have 74.1 grams of oxygen. We want to convert that. I know this is 16 grams of oxygen. This is 1 mole of oxygen. I'm left with moles of oxygen. 74.1 divided by 16.0 is?
4.63.
4.63, okay. Okay. So, what we want to do is we want to figure out this compound, this unknown compound is N number O number, and we don't know how many nitrogens and how many oxygens there are. Okay? Is this nitrogen monoxide? Is this nitrogen dioxide? Is it nitrogen something else? I don't know. And that's what we're trying to figure out. How many N's, how many O's there are. And there's never decimal places in those numbers. They're always whole numbers of some sort. Cool? So I can't put, oh, okay, this is N sub 1.85 and O 4.63. That's the crazy empirical formula of this compound. No, you can't do that. That doesn't make sense. They need to be whole numbers. And so in order to make it a whole number, here's what I would do. If I do something to one thing, I'm allowed to do it to one thing as long as I do it to the other, right? Let's play fair. Math, like basic algebra. So what I'm going to do is I'm going to divide this by 1.85. Ask me why. Or tell me why.
Well, if you do that, it's 1.
Then that becomes 1. Cool? But, alright, so let's divide this by 1.85 as well. So we know that this is N1 and what?
Oh,
O
2.5.
2.5. Okay. We're still in trouble here. Right?
Yeah.
Because this is good because that's a whole number, but this is not a whole number. But at least we're close.
Can't you round?
You can't round. But what you can do is say, okay, well, what if I did this? What if I multiply the whole darn thing by 2? Or maybe better yet, I did this by 2, and this is by 2. Or no, I'm sorry, 1/2. Because that would end up multiplying this by 2, 1/2. And the reason I'm doing that is because 2.5 can be a whole number if I just multiply it by a simple factor of 2. It becomes 5. Cool?
Yeah.
So this would become N2O5. Now this is the empirical formula, and if I were to figure out the molar mass of this, and then I would say, well, of that nitrogen, how much percentage is it? How much percentage is of this compound? How much percentage is nitrogen? I would figure out, oh, it's 25.9% nitrogen. How much percentage is oxygen? I would say, oh, it's 74.1% is oxygen. Does that make sense?
Yeah.
So you can't have like decimals in the bottom, but there are things you can do to play with it, to massage the numbers to make sure that you can get it correct. Cool? Okay. Now, I have a tendency to teach and constantly ask, oh, are you good? Are you understand? And all that kind of stuff. And people get annoyed. And I apologize. And if you guys, if anyone feels that way, then just let me know. And if you feel that way, I mean, you've been my student for 18 years now, or for 15 years now. You're not 18, but I mean, just let me know, because Okay, let's see. Calculate the molecular formula of a compound whose molar mass. Okay, all right. Let's see. All right. So this is 7-14. And the compound formula is CH4N. And you have 60 grams of that stuff. All right, cool. Of this stuff. All right. First thing I'm going to do is I'm going to start off with molar mass. Carbon. What's the molar mass of carbon? Come on.
14.
No. Carbon 12. And I multiply the whole thing by
4. No, nothing.
by 1. Or by nothing, you're right. Hydrogen. What's the molar mass of hydrogen? 1. And I multiply the whole thing by 4. Cool. Nitrogen. What's the molar mass of nitrogen?
17 or is it 14?
14. Like I said, you do enough of these problems, you're going to get good at this stuff. So back when Dad told you, hey, make flashcards and start memorizing these numbers, I wasn't so crazy after all, right? Like it actually like, oh my goodness, I have to do this. So this is 12, this is 4, this is 14. Add them all up, I get 4 plus 4 plus, that's 8, plus 2 is 10, so that's 0, 1, 30. So it's 30 grams per mole. Okay? This thing is 30 grams per mole. I am dealing with 60 grams of this stuff. 60 grams of this stuff. Basically, 30 grams per mole. This gives me a factor of straight up 2. So, what I think that this formula is that correct? Yeah, I agree. Is actually C2H8N2. That's the compound that we're dealing with.
But you just multiply everything by 2, right?
Yep, I just multiplied everything by 2.
So what's the difference?
Because this thing's a factor of 2 bigger than what I was given.
Oh, and you wanted to make it 60 grams.
Yep.
Easy.
Easy. No, coronavirus.